So now that you have seen the values of trigonometric ratios for standard angles, you might be wondering how you got these values. So let us see the rationale of these values. For example, if you want to find sine of 45 degrees. So if you want to find sine of 45 degrees, what you just need to do is, you just need to draw a right angle triangle where one of the angle is 45 degrees. So sine 45 will be opposite side by hypotenuse. So now what is the speciality of this right angle triangle whose one angle is 45 degrees? The speciality is that one angle is already 90. If the other angle is 45, the third angle will also be equal to 45 degrees. That means this is a right angled isosceles triangle. So if the sides are taken as A and A, because these two angles are equal, these two sides are equal. So if these two are A and A, from Pythagoras theorem, you can see that this is A root 2, root of A square plus A square. So now once you have all these sides, you can very clearly see that sine 45 is opposite side by hypotenuse. A by A root 2 is 1 by root 2. Tan 45 degrees is opposite side by adjacent side, which is A by A is equal to 1. So you can very easily find the trigonometric ratios correspond to 45 degrees from this triangle. So now if you want to find the trigonometric ratios correspond to a triangle with angle 30 degrees and 60 degrees. For that, what we do is we consider an equilateral triangle. So let us take an equilateral triangle of side A, and A. Now if you draw a perpendicular from A onto BC. So in an equilateral triangle, so this angle is 90, this angle becomes 60 degrees. So if I draw a perpendicular in an equilateral triangle, obviously this bisects the angle. So the total angle 60 degrees will be converted into 30 and 30. So this triangle have 30, 60 and a right angle. And you know that in an equilateral triangle, the altitude is root 3 by 2 times the side. So AD will be equal to root 3 by 2A, right? And the base will be divided into half. So this can be derived very easily from the geometry. So now once you have this right angle triangle, in this triangle, sine 60 if you want, sine 60 degrees is equal to opposite side, which is root 3 by 2A, root 3 by 2A divided by hypotenuse is A, so A and A gets cancelled, so you get root 3 by 2. If you want tan 60 degrees, you get opposite side by adjacent side, root 3 by 2 by A by 2 is the root 3. So from this triangle, you can very easily calculate the trigonometric ratios correspond to 30 degrees and 60 degrees. Next, if you want sine of 0 and sine of 90 degrees, those are limiting conditions. That is, those are the conditions where you won't get a triangle. Suppose you take a right angle triangle ABC and go on reducing this angle A. Go on reducing this angle A. So in the limiting case, as you go on reduce this angle A, so can you see that this BC goes and goes and goes smaller? So sine A is nothing but sine 0 is nothing but BC by AC, right? So as this angle goes closer and closer to 0, so this BC becomes very, very close to 0 with respect to AC. So BC by AC goes closer and closer to 0. In the limiting case, when A is equal to 0, the value of sine becomes 0. Similarly, if you want sine of 90 degrees, the trigonometric functions correspond to angle 90 degrees. So you have a right angle triangle and you go on increasing this angle going to 90 degrees. So if I want sine of 90 degrees, as you can see, this is the initial right angle and this angle tends closer and closer to 90 degrees. Then obviously this line will become parallel to this line. So there will not be an intersection point. That means the intersection point C goes to infinity, right? C goes to infinity, and because these two are parallel, the length of AC and length of BC will become nearly same. The length of AC will tend to the length of BC, right? Because these two have become parallel. If they touch at infinity, then the length of AC and length of BC is same. So sine A is nothing but, so this side BC by AC. So as A tends to 90 degrees, C goes farther and farther away from A and B, and AC will be approximately very, very close to BC, and this becomes equal to 1. So sine 90 degrees will become equal to 1 if A tends to 90 degrees. So this is how you explain the trigonometric values for standard angles. So if the angle is not a standard angle, if you are asked to find sine of 40 degrees for example, so there is no standard way to derive this, but if you are interested, what you need to draw is you need to draw a right angle, and from, so if this is AB, you draw a right angle. From A, draw an angle of 40 degrees with a protractor or so. So once you form a right angle triangle, you can always measure the length BC and AC, and you can find the ratio of BC by AC, which will be equal to sine 40 degrees. So you can find trigonometric ratios for all the angles by construction. But these angles are special, where you can draw these diagrams mentally and try to get the relations between the ratios, relation between the sides of the triangle. So I hope you have understood the concept of standard angle, values of trigonometric ratios. Thank you.